7, last lesson of the unit. You guys got 2 units left out of 8. That means you're 75% done with the course. Wow, crazy. Okay, so you're like, wait, I don't know anything. Don't say that. Okay, so 543. 543. Okay, in previous lesson we solved quadratic inequalities using graphing techniques by case analysis. So that's what we did, what we talked about. We did a case analysis which you guys didn't like, but that's where we had to solve out the different cases in which things are positive and negative. Okay, in this lesson we're going to introduce a technique called sign analysis. I actually prefer this one. So if you hated case analysis, which was the last one, this one might be the one you like better. Okay, which most of you didn't like the last one. You tried, but you didn't like it. So what you hear is we're just going to test intervals on a sign chart. So what we're going to do is we're going to see how many sections there are to test, and we're going to see if it's positive or negative in that section. Okay, so you know how it goes like through a 0 and comes down and up? We're going to test section 1, section 2, section 3 to figure out the sign of what's going on there. Okay, so solving quadratic inequalities with one variable using test intervals, part 1. The graph of a quadratic function of x squared plus 2x minus 8 is shown below. The zeros are -4 and 2. That's from factoring, because if you factor, it's x plus 4, x minus 2. Okay, so look at this graph. On the interval from x less than -4, so if you're looking before -4, is the graph positive or negative? It's positive. It's up. Okay, between -4 and 2, the graph is that little hump of negative there, yep. Okay, and then after 2, the graph again is positive. Okay, so now what you're going to do is, with an interval chart, we're going to say the sign of it. So less than -4 is negative. Between the two, it's nope, I lied. Sorry. It's before it, it's positive, negative, positive. Okay, I use a symbol. It says write the words, but I use a symbol. You can do what you like. Okay. All right. Any questions so far? It's kind of straightforward. Okay. All right. So then C, complete the following. The solution of the inequality x squared plus 2x minus 8 is greater than 0 for the piece less than -4 and the piece greater than 2. The solution of the inequality x squared plus 2x minus 8 for less than 0 is between the two. X greater than -4 but less than 2. Okay. Okay. All right. Whoops. Okay, so let's do part 2. The intervals determined by the zeros of the function are called test intervals. In solving quadratic inequality without graphing, we use a value of x in each of these test intervals to determine whether the quadratic function is positive or negative. So now we're not going to use a graph. So part 2, consider the inequality x squared minus 9x plus 14 less than 0. Write the inequality in factor form, determine the roots. So let's factor it real quick. So this thing factors to -7 minus 2, right? Okay. And then it says, use the roots of the equation to determine the 3 test intervals. So the 3 test intervals are going to be what? So like, what are the intervals we're testing? So let me show you real quick what it means. I know it's a little confusing. This is what it's doing. Yep, you have it there, Lucas. Okay, that's what it is. And so then Lucas said x less than 2. That's this piece. That's one piece, right? Okay, good. X greater than 7. That's the outside pieces you guys got. So there's greater than 7. Okay, and then we want the in between the two, right? So we want the x greater than 2, x less than 7. What is the sign of the graph there? So what's the sign less than 2? Positive. What's the sign between 2 and 7? The negative, and greater than 7, positive. Okay. Okay, so then what you're going to do when you're not, because a lot of times you're seeing the graph right now, but it says choose any value in the first interval and determine whether it's positive or negative value and write the word. So it's having you test it. So we know, like we kind of already knew because of the picture we drew, but if let's say we're not graphing it, so the x less than 2, pick a number less than 2. Well, that's easy, 0, right? If I put 0 in here, 14. I get the positive we expected. That's how you're testing your interval. You're testing a number that you put within where you're going. Okay? So then like if we try greater than 2, less than 7, let's try 3. 3 squared is 9. Minus 9 times 3 is 27 plus 14. I just tested 3. That's all I'm doing. 9 minus 27 is negative 18 plus 14 is negative 4. I get negative. I'm doing a test for my interval. Okay? And then x greater than 7, we can try 8. Okay? If you try 8, we get 64 minus 72 plus 14. I get 6, I believe. Negative 8 plus 14, 6, I get positive. And so that's how you test without seeing the graph. So if you're not good at drawing parabolas really quickly, okay, just testing them just like that helps. Okay, so that's what we did here. Okay, we just did part C. State the solution to the inequality. So if we say we want less than 0, what's our answer? If we want less than 0, what's our answer? That's the negative section, right? That's the less than section. So the point is, guys and gals, is that there's 3 sections. There's 3 sections. Guys, there's only 3 possible answers. So like if you put x greater than 0, you're just not really paying attention, right? Because like we want 2 or 7 in this case. So you're looking at the zeros of the quadratic that sets your intervals. Those are your options. So once you get these right, you have really have a 50-50 chance. It's either this one or these 2. Okay, so just understand that. But the less than 0 is, yes, it's between 2 and 7. 2 and 7. Here's your solution for when that's negative. Read that this way. When is this parabola less than 0 means when is this parabola negative? Okay. Okay, and then the same one, we're just going to state these all correctly now, paying attention to the signs here. So when is it greater than 0? So it's greater than 0 for less than 2 and greater than 7. When is it less than equal to 0? So then we write the same thing we just wrote above, but we put equal to signs. Between 2 and 7, equal to. And then the greater than equal to 0, we do the same thing in the first part there, but we add the equal to. The values we use to determine whether a quadratic expression is positive or negative, we call those test points. So you can just test any point. You can do that with the shading too. If you think you're not sure if you shaded the right section, you can try something in where you shaded to see if it works. Okay. All right, a couple more here. So then they kind of put into a chart for you. We'll look at it a little bit. Let's do this one first. All right, solve the inequality 8x minus x squared less than or equal to 0 using test intervals. First thing I want to do is factor. Okay, it's important to understand that this parabola, is it going up or down? It's going down, so it's going to change things a little bit, right? So this parabola is doing this. So it's going through 0 and 8. Do something like that. Okay, but that doesn't matter. We know our zeros are 0 and 8. So my test intervals are x less than 0. It is equal to. X bigger than 0, less than 8. And then x greater than or equal to 8. Those are my intervals that we're testing. So we're just going to test them. And it's actually, to me, it's easier to test them in the factored form. So like, for example, less than 0, negative 1. 8 minus a negative 1 is 9. But I'm timesing that by a negative 1, which makes it what? Negative. Okay. Pretend you can't see the picture. We'll relate it to them in a second. Between 0 and 1, let's try 1. 8 minus 1 is 7, times 1 is 7. Positive. greater than 8. 8 minus 9 is negative 1. Negative 1 times 9 is a negative. So you can see what happens here. Before and after are my negative pieces. Between is my positive piece.
So when you graph this flipped, it'll all just be negative.
Right, it's going to flip the pattern for the zeros, yep. Okay, so then it says this one, though, wants less than equal to 0. So that means we want these two are answers. Those are your answers. We want less than equal to 0. So then we write your answer. Another thing that people liked, when I've taught this before, it's inside versus outside, right? Do we want the inside piece or the outside pieces? In this case, we want the outside pieces. The outside pieces are negative. Okay? All right. So we're going to look at the sign chart here real quick. I'd say this might be a little bit extra. Again, if you plan on taking calc, you'll use this quite a bit in curve sketching. But anyways, let's look at it. It's very systematic. So if you like to be really organized, you might like this even a little bit better. At the beginning of the lesson, part 1, Colin solved the inequality of x squared plus 2x minus 8 for greater and less than 0 using test intervals. His older brother who had just completed high school showed him a different method which is useful for solving more complicated inequalities. The method of showing x squared plus 2x minus 8 is shown below. So he went ahead and factored it. He got the zeros of negative 4 and 2 and put them in a chart for your x's. And then he went down here and he put them in a chart of his factors. So what's helpful with this is that you use this to help determine like what's happening. So this is how you read the chart. So you put in negative, like right here, this means less than negative 5, or sorry, 4. So like negative 5, negative 6, negative 4. This is like negative 3, 2, 1, 2, 3, 4, 5, etc. Okay, so what you do is if I put negative 5 here, what's negative 5 plus 4? It's a negative. It's negative 1. We only care about the sign, though. If I put negative 5 minus 2, that's negative 7. We only care about the sign, negative. What's a negative times a negative? Positive. Okay. The zeros, they don't really need that one because it's going to be 0 times something to be 0. That's always going to happen. So this section is not very useful. Okay. Between the two, so let's try 0. 0 plus 4, is that positive or negative? Positive. 0 minus 2, negative. Positive times a negative is a negative. Okay, the 0 again is not too, doesn't really have to help you that much. 3. 3 plus 4 is positive 7. 3 minus 2, positive 1. Positive times positive is a positive. So here is your intervals. This is your positive sections. There's your negative section. Okay, we know that. This graph, we can look at the graph too. This graph was, what is it? It's negative 4 and 2, right? Positives are on the outside. Negatives on the inside. Using a sign chart. Okay, using a sign chart. So since the original equality symbol is greater than 0, look for the solution under the positive product row. So we did that. The product row of positive is those two. Okay, let's try one of those here. We just did minus 8. Yeah, so we just did this answer already. It's the positives. Okay, let's do this last one using the sign chart and we'll be done. Okay, so factor fully the expression of negative 6x squared minus 39 minus 18. We could take out a negative 3. Okay, negative 3 is going to make a difference. I'll show you. That gives you 2x plus 13x plus 6. We're going to factor that now. Okay, just focus on the part in the brackets. 2 times 6 for 12. Remember, a times c. Factor 12 gets you 13. 12 and 1. So we got 2x squared plus 12x plus x plus 6. Okay, so we're going to take the 2 out for the first piece. 2x, yeah, thank you. And this one has nothing, so it's just going to be a 1. So that's going to leave me with 2x plus 1 times x plus 6. And we have the negative 3 still. So that's the completely factored form. So if you're not sure what happened, take 2x out, that leaves an x. Takes 2x out of there, that's a 6. So you get the x plus 6s to match if you weren't sure what happened there. So that's the fully factored form. So I'm going to write it here. So now if they want this. They want less than or equal to 0. So let's do the sign analysis chart. What are my zeros? -1/2 and -6. So actually I want to write the -1/2 second, huh? We're going to go numerical order. So we'll go -6, -1/2. Okay, so okay, that's how you build it. Now here's the thing you got to do with this one. The factors. You need to have your factors, so 2x plus 1 and a x plus 6. Okay, but you also have to count for a -3 because that's going to change the sign, isn't it? So we have to count for the -3. You really don't have to multiply -3. You can just multiply by a negative. But the point is when you use a product, you have to hit by a negative at the end. So it's going to flip all of your answers. So for example, this is always going to be negative. All right, is everybody following me? Okay, so I'll just end this one here. That's 0, so we know that's going to be a 0. I don't care about this. That's going to be 0 there. I don't care about this. Just the 0 sections aren't important for this. It's the parts around. Okay, so try a number less than -6. Let's go -7. If I put -7 here, that's 2 times -7 is -14, plus 1 is -13, negative. -7 plus 6, another negative. If I do a product of those three negatives is a negative. Okay, between -6 and -1/2, let's try -1. So -2 plus 1 is -1. -1 plus 6 is 5, so there's a positive there. So what is that product? Positive. Negative times a negative times a positive, essentially, so positive. Good. Okay, and lastly, let's do 0. That's an easy one, bigger than -1/2. 0 plus 1 is 1, positive. 0 plus 6, positive. And then we have that negative, so it's going to be negative. So for this answer, we want these two, because it says less than 0. So your answer is x less than or equal to -6, x greater than or equal to -1/2. That's using your sign analysis chart. Okay. So all it is, it's organized. If you're kind of lost, if it looks really messy to you, obviously because my handwriting too, but you put your zeros down and you're just trying around your zeros, just seeing what's happening at every 0. Because at the 0 means it's changing, right? When you're at a 0 of a graph, it's going from positive to negative or negative to positive. That's how it's hitting a 0. Okay, so that's what's going on. Okay, all right, we'll stop there.